Hello! In this video, we're going to talk about atoms versus ions. Now to start, an atom has an equal number of protons and electrons. And visually speaking, an example of an atom looks something like this. So notice, we have 1, 2, 3, 4, 5, 6 protons, and we have 1, 2, 3, 4, 5, 6 electrons. So we have an equal number of protons and electrons. Now in an ion, we have an unequal number of protons and electrons. And visually speaking, an ion could look something like this. And so notice in this case, we have 1, 2, 3, 4, 5, 6, 7 protons. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So in this case, we have an unequal number of protons and electrons. Now notice, visually speaking, an atom and an ion had the same sort of structure. They both are composed of protons, neutrons, and electrons. Electrons move around the nucleus. The difference is that atoms have an equal number of protons and electrons. Ions have an unequal number of protons and electrons. And so that's pretty much the idea. So the key idea is that an ion has an unequal number of protons and electrons, which means that we either have more protons than electrons, or we have more electrons than protons. If we have more protons than electrons, then we have a positive ion. And if we have more electrons than protons, then we have a negative ion. And this makes sense, because if you recall, protons are positively charged and electrons are negatively charged. So if we have more protons than electrons, then we have more positive charges than negative charges, which means we're more positive than negative, so we overall have a positive ion. Similarly, if we have more electrons than protons, then we have more negative charges than positive charges. In other words, we're more negative than we are positive, which means we have a negative ion. And so that's pretty much the idea. Now, an atom can become an ion, and it can do so by either gaining or losing electrons. It turns out that if an atom gains electrons, then the atom becomes a negative ion. And if an atom loses electrons, the atom becomes a positive ion. Now, let's see intuitively why this makes sense. So let's suppose, for example, that we have an atom with 9 protons and 9 electrons. Now, first of all, we know that this is an atom because we have an equal number of protons and electrons. Now, let's say our atom gains an electron. Well, after gaining an electron, now we have an unequal number of protons and electrons. More specifically, we have more electrons than protons. So that means we must have a negative ion because we have more electrons than protons. And so this explains why if an atom gains an electron, then we become a negative ion. Now, to see why the second bullet is true, let's again suppose that we have an atom. And let's say in this case, our atom has 12 protons and 12 electrons. Again, it's an atom because we have an equal number of protons and electrons. Now let's say that we lose electrons. We'll say that we lose 2 electrons. So notice, after losing electrons, again, we have an unequal number of protons and electrons. More specifically, in this case, we have more protons than electrons. But when we have more protons than electrons, that means we have a positive ion. And so this explains why if we lose electrons, then our atom becomes a positive ion. And so yeah, that's pretty much the idea of this. So moving back up to the top, let's take some more notes. Okay, now because atoms have an equal number of protons and electrons, we say that they're electrically neutral. Ions, on the other hand, have an unequal number of protons and electrons. So ions aren't electrically neutral. There is some net charge associated with them. And to calculate that charge, it turns out all you have to do is subtract the number of protons minus the number of electrons. Now, let's look at some practice problems. Okay, so question 1. Given an ion with 12 protons and 10 electrons, what is the charge of the ion? Well, all we have to do is take the number of protons and subtract it by the number of electrons. So really, we have 12 protons minus 10 electrons, and so the answer is 2. Now, typically, when writing the charge of an ion, we like to include the sign. So because this is positive 2, we like to include the plus sign. So the charge of this ion is plus 2. And this answer makes sense because we have 2 more positive charges than we have negative charges. Now let's look at number 2. Given an ion with 7 protons and 10 electrons, what is the charge of the ion? Well, again, all we have to do is take the number of protons and subtract it by the number of electrons. So really we have 7 protons minus 10 electrons. This gives us negative 3. So the charge of our ion is minus 3. Another way of looking at this is it says we have 3 more negative charges than we have positive charges, right? That's how you could interpret this, right? And that's pretty much the idea of how you can calculate the charge of an ion. Now, we also like to write ions as symbols. And the symbol for an ion is written with the element symbol with the charge in the upper right corner. Some examples include the following. So as you can see, we have the element symbol with the charge in the upper right corner. The element symbol with the charge in the upper right corner. Right, so those are some examples of ions. Now, another thing you'll commonly see in ion symbols is if we have a charge of +1 or -1, then they'll typically omit the number 1. Some examples include the following. These are examples. Notice, again, we have the element symbol, and then the charge in the upper right corner, the element symbol, and the charge in the upper right corner. But really, the plus sign means a +1 charge. Similarly, the minus sign means a -1 charge. It's just that you'll often see the number 1 omitted, right? It'll often be omitted. Right, just like that. Now, let's look at some practice problems involving ion symbols. Okay, so given the number of protons and the number of electrons, write the ion symbols for the following. Okay, so question 1. We're given the number of protons is 12 and the number of electrons is 10. We want to write the ion symbol for this. Now remember, an ion symbol is composed of the element symbol with the charge in the upper right corner? Okay, well, let's first get the element symbol. How do we figure out the element? Well, you can use the number of protons. If you recall, the number of protons is the same thing as the atomic number. So really, we have an atomic number of 12. We can go to table S to look up the element with atomic number 12. So opening up to table S, we see that an atomic number of 12 is right there, and the element symbol corresponding to that is Mg. So the element symbol is Mg, and now all we need is the charge. Now to get the charge, all we got to do is take the number of protons and subtract it by the number of electrons. Well, that's 12 minus 10, which is plus 2. So this right here is the ion symbol, and that's it. Now, in number 2, we're given 7 protons and 10 electrons. To get the ion symbol, we need the element symbol and then the charge in the upper right corner. Well, let's start by figuring out the element symbol. Again, we're given 7 protons, so the atomic number is 7. So let's go to table S to look for which element has an atomic number of 7. So notice on table S, the atomic number of 7 is right there, and the element symbol is N. So our element symbol is N, and now all we need is the charge. To get the charge, all we got to do is take the number of protons and subtract it by the number of electrons. So 7 minus 10 is minus 3. And so this right here is our ion symbol. Okay, question 3, we're given 17 protons and 18 electrons. Again, let's figure out the element symbol first. To get the element symbol, notice we have 17 protons, so we have an atomic number of 17. So let's look on table S for which element has an atomic number of 17. So notice on table S, an atomic number of 17 is right there. The element symbol corresponding to that is Cl. So our element symbol is Cl, and now all we need is the charge. To get the charge, all we do is number of protons minus the number of electrons. So really, 17 minus 18 gives us a -1 charge. Again, when writing element symbols, what you'll often see is that the number 1 is omitted. So I'm just going to write it like that. And so this is the ion symbol. And so yeah, next moving on to question 4, we're given 37 protons and 36 electrons. Let's first get the element symbol. To do that, because we have 37 protons, we have an atomic number of 37. So let's look on table S for which element has an atomic number of 37. So going to table S, we see right here an atomic number of 37. The element symbol is Rb. So our element symbol is Rb, and now all we need is a charge. To get the charge, all we do is the number of protons minus the number of electrons. Well, that's just 37 minus 36, which is +1. Again, when writing ion symbols, you're often not going to see the number 1. So I'm just going to get rid of it. And so yeah, this right here would be our ion symbol. And so that's pretty much it for these problems. Let's just look at a few other problems. Given the ion symbols, find the number of protons and number of electrons in the following. Okay, so question 5, we're given that our ion symbol has the element symbol Al with charge +3. We want the number of protons and the number of electrons. Let's start by finding the number of protons. Well, to get the number of protons, that's the same thing as finding the atomic number of this element. So let's look at table S for the atomic number of the element Al. So going to table S, we see that Al is right there. The atomic number is 13. And because the atomic number is 13, that means we have 13 protons. Next, we need the number of electrons. How do we get the number of electrons? Well, we can use the charge to do that. If you recall, the charge is equal to the number of protons minus the number of electrons. And we know that the charge is +3 and the number of protons is 13. So we can solve for the number of electrons. So let me take this formula, and I'm going to substitute the charge for +3. I'll substitute the number of protons for 13, and this is just subtracted by the number of electrons. So really we have 3 equals 13 minus the number of electrons. So now you can solve for the number of electrons. And I'll let you guys do that, right? That was good. So if you solve for the number of electrons, you get that the number of electrons is equal to 10. And that makes sense because 3 is equal to 13 minus 10, right? And so yeah, okay, now question 6. This is our ion symbol, right? So we want the number of protons and the number of electrons. Again, let's start by getting the number of protons. Well, to get the number of protons, that's the same as finding the atomic number of the element S. So let's go to table S for that. Going to table S, the element symbol S is right there. And we see that the atomic number is 16. And because the atomic number is 16, the number of protons is 16. So we have 16 protons. Now we need the number of electrons. Well, again, we can use the charge to figure out the number of electrons. So again, using this formula, I'm going to take charge and substitute it with -2. I'll substitute the number of protons with 16, and we're just subtracting this by the number of electrons. Again, you guys can solve for the number of electrons, right? So solving for the number of electrons, you'll get that the number of electrons is equal to 18. Right, and that makes sense because -2 is equal to 16 minus 18. And so yeah, that's pretty much how you can do that. Okay, now question 7. This is our ion symbol. Again, we're going to find the number of protons first. To do that, we're going to figure out the atomic number of the element Na. So let's go to table S. Going to table S, Na is right there, and the atomic number is 11. So the number of protons is 11. And now let's get the number of electrons. To get the number of electrons, again, we're going to use the charge. And remember, when you see a plus sign, that means we have a +1 charge, right? So using the formula for charge, we're going to substitute charge for +1. We're going to substitute the number of protons for 11. And this is just subtracted by the number of electrons. So you can take this equation and solve for the number of electrons, and you'll get that the number of electrons is equal to 10. So we have 11 protons and 10 electrons. And that's pretty much it. Question 8. This is our ion symbol, and again, let's start by finding the number of protons. To do that, we're really just finding the atomic number of the element F. So let's go to table S. The element F is right there, and the atomic number is 9. And because the atomic number is 9, the number of protons is 9. And again, to get the number of electrons, we're going to use the charge. And when you just see a minus sign, that means we have a -1 charge. So going to the formula for charge, we're going to take charge and substitute it with -1. We're going to take number of protons and substitute it with 9. And we're just subtracting that by the number of electrons. So if we solve for the number of electrons, we get that the number of electrons is equal to 10. So we have 9 protons and 10 electrons. And so yeah, that's pretty much it for these practice problems, and that's pretty much it for this video.